Welcome back to my Action RPG tutorial series. Last time we had a bit of a problem with the text resolution on the message boxes after we changed the screen resolution settings. I don't want to spend too much time on that, but basically the problem is that the resolution of the speech balloon depends on the screen resolution and not at all on the camera. We dramatically reduced the screen resolution. I'm going to double the screen resolution. And then in the camera, I'm going to set the zoom to 0.5. So that shouldn't affect the region that the camera sees, but it should give us more resolution for the text. That is better. The main thing that I want to talk about today is how to spawn objects, such as pots, into the scene. When we're creating our levels, we want to be doing as much as possible through tile maps, because painting with tile maps is fun and easy, and having to manually place objects like this pot right here is time-consuming and tedious. But obviously the issue with tiles is that they're fairly static, so if we want to use a tile set to place objects such as pots, we're going to have to be a little bit creative about it. Let's start by creating a new tile set. We will call it prop tiles, which includes pots and potentially other things. For now, we're just going to define a single tile, which of course will be the clay pot tile. Call it pot. In our tile maps, we can define a new tile map, which we will call props. Just remember to set the cell size to 16 by 16. Add the prop tiles to the tile set here. And now we can paint some pots onto the map. Right now, these pots are different than our object pot here that can be picked up and thrown. But what we can do is have our tile map iterate through all of the tiles in this area and replace these pot tiles with the appropriate object. Since we have this camera that nicely shifts to exactly cover each of these 16 by 16 rooms on the map, I think I would like to also have the pots spawn when you move into the room and vanish when you move out of the room. So if you break a few pots and go back into the room, they'll be there again. Doing it this way will also reduce the amount of overhead because we only need to spawn in the objects for the room that the hero is actually in. So let's go to our top level test room script. I'm going to create a new function called move camera. So we will call this whenever the camera changes position. The first thing we'll do, obviously, is camera 2D.position will be set to the new position. Back here in physics process, we're going to create a variable called new camera position and assign it regional position times room size. Now, to determine whether we need to move the camera, let's compare that to the camera's current position. If camera 2D.position is not equal to new camera position, then we are going to want to move the camera to the new position. In addition to updating the camera's position, whenever we move the camera, we also want to spawn everything that's in the prop layer and is also in the region that the camera occupies. To do this, we're going to need to iterate over the 16 times 16 tiles in the current room. Now, if we jump into the documentation for tile maps, we see that there's this handy function world2map, where we give it a world position, and the tile map will tell us the tile map coordinates of whatever that position is. This will let us find the upper left corner of the room in tile map coordinates. So to do this, we will say tile map origin, and we're going to make it equal to props, which is the tile map holding the pot tiles, world2map. This gives us the tile map origin, and then we can iterate over the 16 tiles on the x-axis and the 16 tiles on the y-axis. For x in range tile map origin plus 16, and then iterate over y for y in range tile map origin plus 16. Now we want to find out whether there is a pot at that position. Right now we only have pots, but at some point we would probably want to distinguish between different types of tiles. Going back to the documentation, we see there's a function called getCell, which gets the tile index of the given cell. Tile index equals props.getCell x, y. But what does it mean by tile index? Let's go to prop tiles. there's a little informational icon over here which displays tile names and also their indices. So if we click on that, we see that right now pot is index 0. Suppose we create a new tile, maybe one of these treasure chests, and call it chest. Now, if you look on the tile set, you can see that 0 corresponds to pot and 1 corresponds to chest. Going back to our script, if the tile index is a 0, which corresponds to the pots, then let's just do match tile index. So if it's a 0, that is a pot, and we want to create a pot and place it at that position. So first of all, spawning a pot. We have the pot scene here. We could do a preload, but actually what I prefer to do when spawning objects is to have a factory singleton that can create them. So I'm going to go ahead and create a new scene and call it prop factory. Prop factory doesn't need any special characteristics, so it's going to be a regular node. Give it a name, and I would like to attach a script to it. And in this script, we are going to export packed pot of type PackedScene. So a packed scene is, as it says, an interface to a scene file. Basically, this lets us have one pot stored, which we can instance multiple times with the instance method. And then in the scene editor, I go to prop factory. I click on it. You can see, of course, we exported packed pot. We can now drag this in here. You might say, why do it this way? Why not just preload the packed pot and instance it that way? Well, the reason is if you preload from a path and then you later change the layout of your project, you have to go and find every one of those paths and change it. If I move the pot over into here, if we go back to the prop factory, we can see it's still there. Godot automatically updates the location of that object. Personally, I like to reorganize my projects when they get a little bit unwieldy. Okay, so we have prop factory. It has this packed pot scene set. Now we're going to have a method to create it. Create pot, and this method will simply create a new pot equals packed pot dot instance, and then we'll return that. And of course, in order to be able to access that from anywhere, we have to go into our project settings, go to auto load, and we are going to add prop factory as an auto load singleton. Going back to our test room, if this is a pot, then we want to create a pot. So prop factory dot create pot. We're going to assign that to new pot. We can set the position of the pot using map to world to reverse the world to map transformation that we made earlier. So new pot dot position equals props dot map to world, and then the map position is vector2 xy. And then we will add the new pot as a child of y sort. So y sort dot add child new pot. The last thing we probably want to do here is when we load the scene, we probably want to make the props layer invisible. So set visible to false. Oh, I made another mistake here. TileMap origin is of course a vector, so we want the x component of the TileMap origin and the y component here, because you can't add a vector and an integer. So here I am in the scene, and I enter this room, and you can see the pots have all spawned, and I can pick one up, and I can move around, and I can throw it. So far this is working. However, let's suppose we leave the screen and then return. Now, if you noticed, I picked up a pot, but there's still a pot on the ground. That's because we're spawning them in, but we're not despawning them when we leave the screen. To spawn the pots, we had to go and access the props tile map. But now that they exist, to despawn them, we need to interact with the actual objects. Whenever we leave a room, we're going to want to despawn all spawnable objects. The first thing that we need to do is to mark pots as something that can be despawned. And the way we're going to do this is we're going to go to pots, we're going to go to the node tab over here, go to groups, and we're going to create a new group. We're going to call it despawnable. And that is, anything that's in the despawnable group will be destroyed when it's moved off camera. Of course, that means we need a definition of what it is to be on camera. Let's define a new function, despawn, and we will call despawn right after we move the camera. And what we're going to do for despawn is we're going to iterate over all objects that are in y sort for object in ysort.getChildren. Now we only care if the object is in the despawnables group. So if object.is in group despawnable, and I suppose the hero can pick up objects and move them between rooms. And I guess for right now, let's just say that the objects the hero carries between rooms don't get despawned. We can come back to that in the future if we need to. Let's see, the hero has a carried object variable, so let's just make sure that the object isn't being carried by the hero. So if object is in group despawnable and hero.carriedObject is not whatever this object is, then we will simply queue free the object. Object.queue free. Actually, this line is getting a little bit too long. Let's try to shorten it. So we'll say variable is despawnable. So that is equal to object.is in group despawnable. We'll say is not carried. And that one, of course, is hero's carried object is not this object. And then finally, is not on camera will be... Okay, so first thing we're going to do is we're going to define a rectangular region. And actually, we should probably do this outside of the for loop. Let's comment this out. So we'll call it region, and it will be equal to a new rect2. It looks like the constructor can either take a position and a size, or it can take x, y with height. We already have a position, which is the camera's position. We'll do camera2d.position. And then the size is just the room size. The rect2 class has a hasPoint method, which tells us presumably, yes, if the rectangle2 contains a point. Which means to check if it's on camera, we can just check whether region.hasPointObject.position. And if it doesn't have that point, then it's on camera. I've got an error here. No constructor matches the signature rect2 var. Oh, right. Room size is a float, so we just need to multiply that by a unit vector. All right, I enter the room and the pots spawn. I pick up a pot. I exit the room and come back in. I can throw the pot, and as you can see, there are no other pots underneath these ones. The last thing I just realized looking at this is the pots are slightly offset here. And actually, I think I know why. It's because the coordinates of the tile are, I believe, the upper left corner. If we look at this, you can see the center is right here. This is a pretty easy fix, though. We can just go to where we spawn the pot, and we can add vector2.1 and multiply that by 8 pixels, which is half the width of the pot. All right, and now they are exactly where we said they should be. Pick them up, we can throw them, and if we leave the room and come back in, they respawn properly. So this is going to make it much easier for us to paint our rooms. We can create lots of different types of props and just spawn them in from a tile set and have them despawn and respawn when we leave and re-enter the room, which is also pretty useful for resetting puzzles if the player makes a mistake. That's all for today. I think next time I'll probably talk about how to push objects such as pots around, which will be useful for creating puzzles. Thanks for watching.